emphasize with polynomials is being able to decide whether something is a polynomial or not. And a lot of the equations we work with are polynomials, so we do work with them quite often. So now we're going to kind of also join this in with functions. We talked about functions before. So with polynomial functions, really all that means is we need to set it in function notation, which just means we have an f of x. So if you see an f of x with your equation, that just means it's in function notation. Now it doesn't have to be an f. It could be a g of x. It could be an h of x. It could be an x or not an x. W of x. I think I use sometimes. It actually doesn't even have to be x. But again, in order for it to be a function, we typically set it in function notation. And then there's certain things we can do with functions, certain notation that we'll talk about here in a little bit. And then the other two things on this page were our reviews. So we're still going to classify polynomials by degree, and degree is still the highest exponent. Like this would be degree 4. And then we're still going to make sure we're worried about standard form, which standard form just needs to make sure it's in order. So if something's given to you in standard form, you don't have to worry about rewriting it. Something's not, then reorganize it so you start with the highest exponent and work your way down. So those are two big things that we've already discussed a little bit. So we're going to continue to have them with the stuff we're going to talk about now. Like this polynomial is already in order, so I don't have to rewrite it, but it is in degree 4. The other thing we're going to do is, instead of just classifying it by degree, the highest number, we're going to classify it by something called type. So the next slide, or that big chart that I have down below, is all the different types of polynomials. And it is based off of the degree. So once we classify the degree, then that'll indicate the type that we have. And I actually have them on a poster up here to help you remember the words, because there's 6 different things that we specifically call different polynomials. And then once we hit degree 6, then it becomes a generic. So the first 6 are the ones that are used most commonly, but that doesn't necessarily mean that those are the only types of functions we work with. So even though it doesn't have a special name, it does have a type. So the most basic type of polynomial, everyone with me, so degree is 0. You can actually have a polynomial that's 0. And we actually classified one of these on a worksheet earlier. If it's just a number, it's still a polynomial. I think it was just the number 7. So it's a constant function which just has a single number. So if f of x equals 5 or f of x equals 10, that is considered a polynomial. Its degree is 0, and it's called a constant function. We've actually worked with these a little bit in the past already. We just maybe didn't call them constants. Anytime we graphed a horizontal line, that's actually a constant function. So that's degree 0. Degree 1, so again, if you look at your exponent, there's an x, but you don't see the exponents of 1. That's a linear function. We've actually worked with linear functions before. Anytime you work with y equals mx plus b, that was a line. We graphed those. We did a whole bunch of things of those within algebra 1. So those are considered polynomials as well. We just maybe didn't call it a polynomial then because we were just specifically talking about that. The next one is quadratic. This is the one that tricks people up a little bit. So it's degree 2, so its highest exponent is 2, and it's called quadratic, which a lot of people want to say quad is 4. And I know that that's the typical prefix for that. So I don't know exactly why they switched it up there, but they've always called it quadratic, so that's what degree 2 is. And we've talked a lot about quadratic functions last unit. So we graphed them, we used quadratic formula, we factored, we did all that with quadratics. It's also a polynomial, so it's still included in this unit. And then for standard form here, again, the highest exponent comes first, and then it is a possibility for you to have all the other terms underneath it. So this one has a quadratic term, a linear term, and a constant term. That doesn't mean that every single quadratic equation or quadratic function has to have these things. But what makes it quadratic is that first term, and then it can have everything underneath it. So we can have ones that just have that. We have one that just has a quadratic term and a constant. So it doesn't. So that in the standard form column, just because you see that term underneath it doesn't necessarily mean that every one type of those functions have to have all of those terms. So those are the 3 that we've actually talked about in other contexts before. Constant, like so those are our horizontal lines. Linear, we did a whole bunch of stuff with that when we're making our lines. Quadratics, we did a lot of that with the unit before. So then we start talking about some of the newer functions. A degree 3, its highest exponent is 3, is called a cubic function, which makes sense because we've called exponents of 3 cubed for a little while now. But again, that's a cubic function. And again, what makes it cubic is its highest exponent term is an x to the 3rd power. And again, it could have everything underneath it as well, or it could have a mixture. And we've worked with polynomials enough for the last couple weeks that we know that we don't have to have every single thing included underneath it. But in some cases, like when we were doing the division, we had to make sure those terms were included. So just a couple things about that. Then the next one is degree 4, and that's a quartic. So remember, we've used that word quart in the past. We just add ick to it, so quartic. Okay. I remember that one as 4 quarts in a gallon. But again, that's degree 4 is quartic. So again, what makes it quartic is its highest exponent is x to the 4th, and it can have everything underneath it as well. But it doesn't have to in order for it to be a quartic. So again, what makes this particular equation quartic is as an x to the 4th. Okay. And then the last word that we have for a specific type of polynomial is degree 5, and that is quintic. And that one actually makes sense because the prefix quint actually means 5, so it's quintic. And again, it has to have an x to the 5th, and that's the highest exponent we have. So those are the only types of functions that have its own specific word. Once you hit degree 6, it becomes generic. So the type of function for degree 6, we just call that 6th degree polynomial. And then again, what makes it a 6th degree polynomial is its highest exponent is 6. So now I do have a dot here, because that doesn't mean that the list stops, okay? Because we can actually have any number of degree that we want, but after we hit 6, it's just a generic term. So degree 7 would be 7th degree polynomial. Degree 8 would be 8th degree polynomial. Degree 9 would be 9th degree polynomial. Degree 10 would be 10th degree polynomial. So they all still have a type, it's just not a specific word. We just go to the generic label of 6th degree polynomial, 7th degree polynomial, 8th degree polynomial. Does that make sense? Okay. So when we're talking about polynomials, we're going to classify it by a couple things. We still state the degree, and now we'll state the type, and then also make sure it's in standard form. So if something's already in standard form, we don't have to rewrite it, but if it's not in standard form, then you do have to reorganize the terms so that they are. So
would the standard form be like that?
Yep. Yeah, but instead of A's and C's, it's numbers. And they don't have to have all of these terms. It's like if your thing just had an x to the 5th, an x squared, and an x, you just have those 3 terms. So you don't need to add anything in. There's a possibility that with an x to the 5th, we could actually have 6 different terms in that equation. It's a possibility. You don't have to. So those are the different classifications we're going to use for polynomials. Then real quick before we do some examples of the classification, I have a slide of the reminders of what makes something not a polynomial, which I actually have this as in a sentence form in an earlier note packet, but I just wanted to re-go through it because it's been a little bit, especially with our snow days, since we've talked about what makes something not a polynomial. So if you see any of a term like this in one of your polynomials, it's not a polynomial function. So these are the 5 things you can't have. And with this one, I made it more of a list and put like a little example of what it looks like next to it. So that way when you see negative exponent, that one's pretty straightforward. But variables in the denominator square to variables. So if you see something like that within your equation, within your function, it's not a polynomial function. So negative exponents you can't have, variable exponents. If you have a fraction, the variable can't be in the denominator. Like you could have actually 3 over x, that's fine. Or sorry, x over 3, that's fine, but 3 over x is not. You can't have a square root of a variable, and they can't have different variables in order for it to be a polynomial function. So what I mean by that, again, you can't have x's and y's in your equation, whether they're being multiplied together or added together. You can't have different variables. So it has to be x all the way through or y all the way through. You can't have 2 different variables. Okay, so like I said, hopefully that list is familiar because we talked about what makes it not a polynomial in the past. But again, I wanted to really make sure you have a list format for what we're looking for what makes it not a polynomial. So with this one, So first going to say yes or no if it's a polynomial or not. If it's yes, then we have a few things to do. So then we're going to identify its degree, type, and make sure it's in standard form. So those are the three things we look for if it is a polynomial. And then if it's not, you give me a reason why it's not a polynomial. So you can either circle it or tell me a little bit about it. A good explanation, if I'm not asking you to do a full sentence, is just use one of those phrases. Negative exponent, variables in the denominator, square roots of variables, different variables. So you can use one of those phrases or circle the term that makes it not a polynomial. So let's look at the first example. So if we look at this equation, is this a polynomial? Are there any negative exponents? Exponent?
Oh, no.
No. There's no variable exponents. There's no square roots. There's no fractions. You don't have to worry about variables in the denominator. And also, it's x throughout, so there's not different variables. So is this polynomial?
Yes.
Yes. Okay. So yes, this is a polynomial. So if something's a polynomial, we're going to say two things about it. And then we're going to make sure it's in standard form. So what would the degree of this polynomial be? 4.
3 or 4.
4, yep, highest exponent. So it's not quite in order yet. We'll fix that in a second. So it is degree 4. And once you decide what degree it is, that leads you to the type. So if we look back at our list, degree 4 is...
Quadratic.
Yeah, that one's hard to say. It's quartic because it's quart with an ick at the end. So quart. Tick. Quart. Quart. And then, so we did degree, type, and then make sure it's in standard form, which it's not, because in order for it to be in standard form, what terms needs to come first? Yep. So the highest exponent, so x to the fourth. So the x, that needs to come first, then the negative 0.8, x to the third, then the 5. So there's the first one. Now, like I said, if it was already in standard form, we wouldn't necessarily have to rewrite it. That one wasn't, so we needed to rewrite it so that it was. Questions on the first example? Okay. Second example, is that a polynomial?
Yes.
Yes, it is. So what's the degree? 5. So if it's degree 5, what type is that? Look back at our list. Quintic, yeah. A lot of Q's. And then is this in standard form?
No. Yeah. No.
No, it's close. Okay. The highest exponent is first, that's right. So the 2x to the 5th needs to be, well, what needs to change?
3 and the 2 need to move.
Yep, those middle two x's. So it needs to be negative x to the third, then x squared, and 1. What about the third one? No, it's not. Okay. Why is it not a polynomial?
Negative exponent.
Yep, and negative exponent. Like I said, you can just use one of those phrases that I had on last slide. Negative exponent, variable exponent, variables in the denominator, square root of variable, different variables. You can use one of those phrases to explain why, or you can just circle. That's fine. Questions about the classification part? Okay, so that's the main thing with the new vocab. Is getting used to those types. Like I said, I do have it up on a poster, so that way it'll help you. And then I'll always let you use this, so that way you don't have to necessarily memorize all the words and also all the things that make it not a polynomial. So you'll at least be able to use this no matter what. So then also, since we talk about functions, the other thing we can do with it is evaluation. And we've done stuff like this in the past, so it should seem a little familiar. The biggest difference is that now we're working with equations that maybe have higher exponents than maybe we've used before. And then we also may be asked to substitute different things into our function other than just numbers, okay? So like I said, we have done this a little bit in the past, so if it seems familiar, that's why. But we may not have done it with these particular types of equations or this particular stuff that I'm asking you to do with it. Okay? So sometimes I'll give you a function and I'll ask you to evaluate for two different things. Okay? So here's our function. It's a quartic function because it's an exponent of 4. And then down below here I have two things. We have f of 3 and f of a squared. So when I see something inside parentheses like that next to f, what am I asking you to do with that 3?
Replace the f.
Yeah, it replaces the x's. So we're going to take that 3 and put it in for all of the x's in the function. So it'll be 2 and then 3 to the 4th minus 8 times 3 squared plus 5 times 3 and minus 7. And then once we do f of 3, putting 3 into our x's, now we're going to solve it out. Okay? So I go to term by term. So if we look here at this 2 times 3 to the 4th, order of operations tells us to do what first? Exponents. So we're going to do exponents before we multiply. So that's the common mistake. A lot of people, I know it's very tempting because we're used to reading from left to right. A lot of people want to take 2 times 3 first, but we actually have to do 3 to the 4th power first, which is 81. Then we take it times 2. And I'll go ahead and do that. So that's 160. So whenever you see a term like that, do the exponent first, then take it times the number in front. So 3 to the 4th is 81, then take it times 2, 162. Now I'm going to move on to the next term. Again, what do I need to do first here?
Times it.
Exponent. So 3 to the 2nd power is 9, then take it times 8, so that's minus 72. Then I move on to the next term. This one, do I have to worry about an exponent? Nope, so I just take 5 times 3 is 15. And then minus 7. So this way I like to do it because then if you go and do term by term, then the very last thing, all you have to do is add and subtract from left to right. So I'm just going to do 162 minus 72 plus 15 minus 7. Do that all at once, so we get 98. And I will suggest doing that because some people, if you start doing some of the addition and subtraction first before you finish all the multiplication, that might mess it up because again, order of operations tells us to do exponents, multiplication, then addition and subtraction from left to right. Okay, so do make sure you're careful with that because really once you get it all substituted in when you do the evaluation part or the solving part, you have to make sure you're really good with order of operations. Okay. So I did my exponents, multiplication, all that first. Then I just add and subtract from left to right. Okay. So then I also sometimes then ask you to use the same function and ask you to substitute another thing in. This one's a little bit different because now we're substituting a variable with an exponent. So that's maybe something unique we haven't really done much with up to this point. Okay. So again, when I see the a squared, where am I going to put that? In for all the x's. Yep. So let's do that. We have to keep both exponents around. So the exponent that was already with a and the exponent that was with x. This is where it's a little bit different than what we've been doing with exponents before. Because when we took like an x times x squared, it became x to the 3rd power. Here, we have to do exponents first. Now, if there was a number in front, that would be a little bit different. We'll talk about that in a second. But again, with this one, we're taking a to the 2nd to the 4th. Remember what exponents tell you to do is take a to the 2nd times a to the 2nd times a to the 2nd times a to the 2nd. Okay? So then how we actually can simplify that is because technically there's 4 of those. You want to remember what we do with our exponents when there's 2 of them? That's where it's tricky. You actually multiply them. Okay. That's where it's a little bit different than what we've been doing. So what we've been doing is x times other x's, then you add the exponents. But if you give something that has an exponent another exponent, you actually multiply them together. So that's where the exponent rules get a little goofy. So again, so if you have a to the 2nd to the 4th, a squared times a squared times a squared say 2 because there's nothing to multiply it with. So it's 2a to the 8th. Then we have a squared squared. So what's that going to become?
A to the negative.
Yep, a to the 4th. This one, is there really going to be anything that changes with this one? No. Okay. And then we don't know what a is, so that's it. So if you're substituting variables, there's some things you can simplify. Like this one, we were able to simplify some exponents, but we aren't able to get all the way down to a single number like we could with that first substitution because we don't know what a is. So we just take our equation and now put it in terms of a's instead of x's. Questions about these? So for the most part, I try to give you a pretty straightforward substitutions like the first one, but I do want to do a few more examples where we're talking a little bit more about some trickier substitutions. Like with this one, there's some different things that we have to do with our exponents. Then there's some other things that happen when you're substituting negative values in. So we're just going to do 2 more examples with some substitution where it's a little bit, there's some unique things that happen. So I want to talk about that. So with this one, we're still substituting a number, so our answer is going to be a number. But the big thing is we're substituting a negative number into our x's. So that's, again, that's what that's telling us to do. So I'll go ahead and get that set up. And this is actually notation, this first part, so if you actually don't end up writing that down, I'll be super picky about that. But again, we'll take the negative 2, we're going to put it in for all the x's. So this is where negatives, again, you have to make sure you're careful with them because negatives are always a little pesky. So when you take negative numbers raised to different exponents, different things happen. So like if we're going to talk about this first one here, we're taking, we have to do the exponent first. So we're going to take negative 2 to the 5th power, which that's telling you to take negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Okay? Because there's technically 5 negative 2's. When you take something to an odd exponent, it's going to remain negative because negative 2 times negative 2 is 4. Negative times another negative 2 is negative 8. Times another negative 2 is 16. And times another negative 2 is negative 32. Okay? So when you take something to an odd exponent that's negative, it's going to stay negative. Okay? Now the nice thing is the calculator will help you out with that. The one thing I will suggest, especially if you're using my regular calculators, these have a hard time with negatives in front of numbers. So the way you can always get the correct answer if you're using my calculator is if you put the negative number in parentheses. So if you do parenthesis negative 2 and then close that parenthesis, and then my exponent key on my blue calculators, I'm going to put a box around it so you know that's a calculator button. That's a little exponent key. And then some calculators have this variant, okay? So again, that'll always give you an exponent. So that way, instead of having to do negative 2 times negative 2 times negative 2, but manually your calculator, you can use that to help you do higher exponents quicker. So you can do negative 2, and then, like I said, if it's negative, I would really highly suggest putting it in parentheses. Otherwise, sometimes the calculator doesn't read the negative quite right. Then do exponent 5, and then you get the negative 32, okay? So then we have to take that times 3. So we get negative 96, which I don't know why I did that. So you have to be really careful when you're taking negative numbers to exponents. So if it's odd, so if there's going to be, it's still going to remain negative. So anything to the 3rd power or the 5th power or the 7th power, the number will remain negative. Now if you take something to an even exponent, that's telling you to take negative 2 times negative 2 times negative 2 times negative 2, that's going to end up being positive, okay? So you have to really be careful with the negatives when you're taking it to exponents. And again, the calculator will do it for you, just as long as you make sure. I would always suggest putting that in parentheses, but otherwise the calculator doesn't always read the exponent correctly. So that's going to be 16 when you do that. So here's the other thing I'm going to back up and talk about. I know since we started talking about the double negative, people want to try to change that right away. because it's very tempting because you have the two negatives, but you actually can't change that negative yet, because if you do the double negative change, that actually is doing the subtraction before you do the exponent. So you have to make sure you do the exponent first, which negative 2 to the 4th power actually ends up being 16, so that subtraction is going to stick. So it is going to stay negative, because the negative is going to go away when you take negative 2 to the 4th power. Because negative 2 times negative 2 is 2, then times another negative 2 is negative 8, then times another negative 2 is positive 16. So you do have to make sure you're careful with all those negatives. So we can't change this yet because that's doing the subtraction first. So you have to do negative 2 to the 4th power first, which is 16. So that subtraction is going to stay there. Okay. Now this one, do I have to worry about an exponent? No. So you can just take 5 times negative 2. And then with this one, that is going to change because it will have a negative 10 here. So I have a negative and another negative, that is going to switch it to a positive. So do make sure if you have an exponent, do that first, and then multiply if you have to. Okay. And this other 10 is going to drop down. So you have the negative 96 from taking negative 2 to the 5th power first, which is negative 32, then times 3. Then we took negative 2 to the 4th power, which is 16, but it stayed negative because the negative went away when I did the exponent. This became a positive because I have a double negative here, and then that 10. So then, once I've done all my exponents and multiplication, then I just add and subtract from left to right. So negative 96 minus 16 plus 10 plus another 10. Wait, negative 92. So just be really careful with your negatives when you're substituting it in with exponents. Okay. Then here's the last kind of strange one. So we did just a variable with an exponent. Sometimes we can substitute a variable and a number, not an exponent. That changes up a little bit what we do. Okay. So yeah, whenever you see that stuff inside the parentheses, that's telling you substitute. Everybody with me? Okay. So with this one, it's telling you to take, again, we have to do exponents first. It's telling you to take 3y to the 6th power. So it's telling you to take 3y times 3y times 3y times 3y times 3y times 3y. Okay? So both the 3 and the y are going to get the exponent. So the way to do it quickly is to do 3 to the 6th power in your calculator. So 3 to the 6th power is 729. And then the y is also given the 6th power, but we don't know what y is, so it stays y to the 6th power. So whenever you have a variable and a number with multiplication here raised to an exponent, saying 3y times 3y times 3y times 3y times 3y times 3y, which means you need to take 3 to the 6th power, and also y needs to be to the 6th power as well. So both the variable and the exponent get the exponent, or the variable and the number get the exponent. Then, again, we take it times the number in front. So again, do the exponent first, then take it times the number in front. So that's going to be that makes sense. So I did 3 to the 6th power and y to the 6th power. Then I took that number times 4. Okay? But y still is to the 6th power, because it has to stay in the 6th power because we don't know what y is. So then here, what do we need to do 3y to the 3rd power?
Times 3 times 3 times 3.
Yeah. Do 3 times 3 times 3, which is 27. And then y needs to be the 3rd power, but it says y to the 3rd power. Then we take it times 5. So 27 times 5.
135.
Yep. And it's y to the 3rd. So yeah, whenever you have that group to the exponent, make sure you give it to the number and the variable. Here we don't have to worry about an exponent. So what's the only way we can simplify this thing? Yep, negative 3 times 3 is negative 9y. And then we have the 5. all we can do because we don't know what happens. So like I said, if it's just a nice positive whole number, very straightforward to evaluate. When it's negatives, be careful with the negatives. When there's some variables thrown in there, just make sure you're careful with all the little things. Again, do all the exponents, multiplication first, and then if you can, add, subtract from left to right. If there's still a variable, just kind of have to leave it. So today, there's no exit ticket, so you just have to do a worksheet. And there's 8 questions. So the first 4, you're doing classifying polynomials. So yes or no, is it a polynomial? And then if it is, state the degree, type, and make sure it's in standard form. If it's no, say why. And then the last 4 is evaluation. 5 and 6, you have 2 things to substitute. So 5 and 6, you'll have 2 separate answers for both of those. And then 7 and 8, you're going to just substitute 1 thing in, just kind of like we did with these last 2 examples. So and there's some variables in that.